Hello everyone, thanks for tuning in. So in today's lecture, we are going to do examination style past paper questions on equations. Now when it comes to equations, we are going to do linear equations, non-linear equations, and by non-linear, in this context, we are talking about quadratic equations, and we shall also be doing questions involving simultaneous equations. So let's get to it. Here we have number 7 of some past paper question. They're telling us to find the point of intersection of the lines 3x plus 2y is equal to 6 and x plus y is equal to 4. Now, when they're telling us to find the points of intersection between two lines, they're actually trying to ask us to find the values of x and y that where those two lines agree. In other words, when two lines meet, in other words, let me say, if this is a line, and this is the line 3x plus 2y is equal to 6, and then we have another line right here, and we are calling this line x plus y. When you see those two lines, they're going to meet at that point. Now, at the point where those two lines meet, it means that at that point where they meet, the value of x and the value of y at that point are the same. So if the value of x and the value of y are the same at that point, that is exactly what they're indirectly asking us here, to find the point of intersection where the lines meet. And so this is as simple as solving these two equations simultaneously. By solving those two equations simultaneously, you'll be able to find the values of x and y where these two equations, agree. Now, there are various ways of solving simultaneous equations. You can solve them using substitution method, you can solve them using elimination method, you can solve them using graphical method, you can solve them using matrix method. I have a video that describes all these four formulas. But since I'm just answering questions, let me just use the most convenient method here to solve simultaneous equations. So here we have 3x plus 2y is equal to 6. I'm going to use substitution method. This is my equation 1. So we have equation 2 here, which is x plus y is equal to 4. This is equation 2. So what I'm going to do is that I'm going to make the x the subject of the formula in equation 2, and then I will substitute for the value of x in equation 1. So if this is x plus y is equal to 4, so that means that x is going to be equal to 4 minus y. So I have made x the subject of the formula. So in the place of x, in the first equation, this is what we call substitution. So this, I'm going to come and replace it there. So it means that I'm going to come and get equation 2 and say 3. Now where there is x, I'm going to put this 3. In the place of x, I put 4 minus y. That's what we call substitution method. Plus 2y is equal to 6. So I have done that. So meaning that in the first equation, we only have y as the unknown. So we continue to find the value of y. 3 times 4 is 12. 3 times negative y is negative 3y. That is plus 2y is equal to 6. So that's going to become 12. Negative 3y plus 2y is minus y is equal to 6. So from here, we shall end up with, we can say this is 12, 6 comes this way, it becomes minus 6 is equal to y, and that 6 is equal to y. So we've gotten our value of y as 6. So after getting our value of y as 6, I can simply come in here and say, therefore, y is equal to 6. After getting our value of y as 6, then I can come and just pick on any of those two equations to find the value of x. So I can still, I can choose the, this one, the second equation, which is x plus y is equal to 4. Now, let me substitute this to find the value of x. Remember, we got our value of y as 6. So it's going to become x plus our value of y, which you got as 6, is equal to 4. So x is going to be equal to 4 minus 6. Our value of x here is negative 2. So this simply means that to answer the question, that question says that find the point of intersection of these two lines. So meaning the point of intersection is, so you can come conclude and say the point of intersection of those two lines is x, which is negative 2, comma y, which is 6. So it's negative 2, comma 6. That's where the two lines intersect. That's where the two lines agree. So next number, Find the equation of a line whose gradient is -1/2 and passes through that point. So we need to find the equation of the line whose gradient is -1/2 and it passes through the point -4,5. So now what is this number, the gradient? Now we know that we're dealing with the equation of a straight line. We know that the general form of the equation of the straight line is given by y is equal to mx plus c. That is the general form or the general structure of how a straight line equation looks like. And we know that from this, that the value of m represents the gradient of that line, and the value of c represents the y-intercept of that line. That's what we know. So now in this, the question says that find the equation of the line whose gradient is -1/2. It simply means that we already now know the value of m as -1/2, and it's passing through point -4 and 5. It means that -4 is our value of x and -5 is our value of y. So it means that as far as this is concerned, we have a value for the value of y, we have a value for the value of x, we have a value for the value of m, which is the gradient, and so all we need to find is the y-intercept. And after finding the y-intercept, then we can reformulate the equation, and there we have it, because they want us to find the equation of the line. So let's get started. So we're going to substitute. We know that y is equal to mx plus c, and we know that our value of y, we have 5, is going to be equal to our value of m, which so happens to be the gradient, which is -1/2 according to the question, times the value of x. Our value of x is -4 plus c. So let's go on and find the value of c. So to find the value of c, so this is going to become 5 is going to be equal to by 2 once by 2 twice. -1 times -2 is +2 plus c. So that means the value of c is 5 minus 2, which is 3. 3 is equal to c. So now that we know our value of c as 3, so we can go ahead and say, meaning our value of y is going to be m, which is the gradient, which is -1/2 x, plus our value of c, which is 3. And that's the answer. So we've gotten the equation. Moving on. Solve the equation 2x squared plus x minus 1. Now this is a quadratic equation. This is 2x squared plus x minus 1. So we are going to solve that equation by factorization. Yeah, solving the equation means they want us to find the value of x. So of course, to solve that equation by factorization, we are going to first begin by saying that we are supposed to split this middle term here, right? We want to split this middle term so that there are 4 items. Right now there are 3. If you can see, there is this, there is that, there is that. Those are 3 terms. So by splitting this middle term into 2 so that it becomes something like something plus something plus something plus something, when they become 4 terms like that, it means that we can group them into 2 brackets and we are able to factorize them and find the answer. That is the intention. So we want to split that middle term right there. So in order for us to split this middle term, which so happens to be positive x, we are supposed to get 2 numbers, which when we add them, they give us a sum of, the coefficient of x, which is +1. When we add those 2 numbers, it gives us +1. And when we multiply those 2 numbers, it's going to give us a product of, a product of this, the coefficient of x squared times the last number. The product here is supposed to be giving us the 2 times -1, which is -2. In other words, we are looking for 2 numbers that when we add them, they give us +1. When we multiply them, they give us an answer of -2, like that. So how do we find those 2 numbers? We find those 2 numbers by going through the products of -2. So let's get started. So what are these 2 numbers? Let's look at going through the factors of -2. So we have -2 times 1 Negative 2 of times 1 gives us negative 2. Does it give us positive 1? No. However, if we play around with this negative and we simply say maybe 2 times negative 1, 2 times negative 1 still gives us negative 2, but 2 plus negative 1 will give us positive 1. So meaning that these are the two numbers that will work. So these two numbers, 2 and negative 1, are the ones that are going to go ahead and displace that middle part. So it means our next step is going to become 2x squared. So the middle part is going to be replaced by these two numbers. Instead, we are going to put them there with an x to them. Okay, so it means it's going to become plus 2x minus x. Notice that positive 2x minus x still gives us positive x up there. So meaning that the original thing has not been changed. We've only split it into two like that, using some two numbers. Negative 2x minus x gives us positive x, which is the step before. We've only split the two. So it's 2x minus x, then we continue minus 1, like that. Then from there, we can go ahead and factorize. Okay, like that. So what's the common item here? We have 2x is common. We put 2x outside the brackets into 2x squared divided by 2x gives us x. Then positive 2x divided by 2x gives us plus 1. Then same thing here. What's the common thing? Remember, we put this in mind that we want the items in the brackets to be the same. So we can simply come here and say it's minus 1 outside the brackets into negative x divided by negative 1 gives us positive x. Then negative 1 divided by negative 1 gives us plus 1. So from here, you're able to realize that the terms in the brackets are the same. So we put the terms in the brackets in their own brackets. So that means it's going to become 2x plus 1 into the terms that are outside the brackets, which is this 2x minus 1. So we put those in their own brackets, so it's 2x minus 1. Now you will forgive me, remember our question is saying it's equal to 0, so this is supposed to be equal to 0, equal to 0, equal to 0. This is equal to 0. I have forgotten to put that equals. Okay, so let's proceed. So we have x plus 1 into 2x minus 1 is equal to 0. So now, what we know that any number multiplied by 0 is going to be equal to 0. I mean, 2 times 0 is equal to 0. 10 times 0 is equal to 0. Anything multiplied by 0 is equal to 0. So it means that if we are having this bracket multiplied by that bracket giving us 0, it simply means that one of these brackets has to be 0. That is the reasoning. So we shall simply come and say either x plus 1 is equal to 0 or 2x minus 1 is equal to 0. Therefore, here the value of x is equal to negative 1, or the value of x here is 1 over 2. That is just by making x the subject of the formula, and those are the two values of x. And by so doing, we have solved that equation, this quadratic equation. So moving on. Again, here they're asking us to solve the following pair of simultaneous equations. 5x minus 9y is equal to 1 for y minus 2 is equal to x, like that. Again, you can solve using substitution, you can solve using substitution, elimination, you can use graphical method, you can use matrix method to solve simultaneous equations. If you want how those other methods are done, I have a full video on it. Just let me know in the comment section below and I will be able to share the link right there. So what we do here is, let's use substitution because it is easier, right? It is way straightforward from this point. So from here you can see that the value of x is already, in the second equation, x has been made the subject of the formula, right? So the easy thing to do is that these values of x, that whatever is in that brackets, we come and fill it up there in that value of x. That's what we call substitution. So this is 5 into the values of x, we put 4y minus 2 minus 9y is equal to 1. So 5 times 4 is 20y minus 5 times 2, 5 times negative 2 is negative 10, then minus 9y is equal to 1. So what we have here is we have 20y minus 9y. Okay, let me rearrange it. 29 minus 9y minus 10 is equal to 120 minus 9 gives us 11y. 11y is equal to 1. This 10 goes this way, becomes plus 10. So we have 11y being 11. Divide both sides by 11. When we divide both sides by 11, this goes with that, we remain with our value of y as 1. So now that we have our value of y as 1, we can go ahead and find the value of x by substituting for the value of y in any equation here. Let's substitute in the second one. So we can simply come here and say, okay, we know that 4y minus 2 is equal to x. So 4 times y, now remember our value of y, we got it down here as 1. So if our value of y is 1, we shall come and put it right there. So 4 times 1 minus 2 is equal to x. So that is 4 minus 2 giving us x. And of course 4 minus 2 is 2 is equal to x. Therefore our value of x is 2. So yeah, that's the answer. Our value of x is 2 and our value of y is 1. If you want to prove to see whether your answers are correct, it's as simple as substituting for these values of x and y into your equations. And when you substitute them, they're supposed to agree. For example, in the first equation, 5 times x, 5 times x, that is 10. 5 times 2 is 10, minus 9 times y, which is 1. Is giving us 1. It satisfies the first equation. If I substitute the same values of x in the second equation, 4 times y is 1. So it's 4 times 1, which is 4, minus 2 is going to give us the value of x, which is 2. Yeah. So that shows that the answers are correct. Next, find the equation of the line passing through the point 2, 0. So we have a line here. We want its equation, but this line is passing through point 2, 0. 2, 0, and is perpendicular to a line, and it is perpendicular. Perpendicular means that they are meeting at 90 degrees. Let me try and use a different color there. And it is perpendicular to a line, to the line joining points negative 10, 3. So this is negative 10, 3. This is just a sketch. They are not actual points. And that is 6, negative 9. Like that. That's the question. So we have a point, a line here. It's in green. They're telling us that we need to find the equation of this line. This is the equation they want. Find the equation of this line. But what we know about the equation of this line is, what we know about this line is that it is meeting this other black line perpendicularly. And this other black line is passing through these points and that point. Now, these are two lines that are perpendicular. Now, first of all, for us to be able to get the equation of this line, we know that the general equation of the line is given by y is equal to mx plus c, right? That's what we know. And according to the green line, we have to, we have a point, at least a point where the line is passing through, which is x, y. So it means that there we have a point x, we have a point y. Now what we need to get the rest of the equation is that we need m, which so happens to be the gradient, and we need the y-intercept. Now, we can get the value of m, or we can get the gradient of this line. How do we get it? We get a clue of that from the other line, the second line, the black line. The black line, they're telling us that it is perpendicular to that line. Now, what do we know about gradients of two lines that are perpendicular to each other? If we have two lines that are perpendicular to each other, in other words, they meet at 90 degrees, and the line of this one, this is m1, the gradient of line 1 is m1, the gradient of line 2 is m2. When you multiply those two gradients, in other words, the gradient of line 1, which is m1, multiply that by the gradient of line 2, which we are calling m2. When you multiply those two, they are supposed to be giving you negative 1. So it means that if we can get the gradient of line m2 right here, then it can help us to get the gradient of line 1, which so happens to be the value of m we are looking for here. And then we are able to figure out the equation of that line. So that is the concept, a background concept you should know, that when two lines are meeting at 90 degrees, their gradients multiplied are supposed to be equal to -1. Of course, this goes without saying, if you have two lines that are parallel to each other, and this is gradient m1 and that is gradient m2, when the two lines are parallel, the gradient of line m1 is the same as the gradient of line m2. This is when they are parallel. When they're perpendicular to each other, you know, the two gradients, when you multiply them, it gives you -1. So if you know the gradient of one line, it's easy to get the gradient of the other. So let's get to it. So let's try and find the gradient of the green line. How? By trying to find the gradient of the black line. We can easily find the gradient of the black line because we have 2 points there. We have 2 points along that black line. So it's easy. So let's get to it. So we also know to find the gradient of the black line that I'm calling M2, we know that gradient of the black line, which is M2, the formula for gradient, again, these are things that must have been introduced to you in your class. I'm just quoting formulas. I'm not going to explain where they come from. So that's going to be y2 minus y1 over x2 minus x1. So that's going to be now what is y2? Let's label some of these things. So here we have this as, we just label, you can label any. This is x1, y1, and this is x2, y2. It doesn't matter which one is x1, y1, y2. If you, or maybe you can choose to make this one x1, y1, and that is x2, y2. It doesn't matter the order, as long as you maintain the ones and the twos to be together. So that is y. So we shall come here and say what is y2. Our y2 is 3. So I'll come here and say this is going to be 3 minus y1. Our y1 is -9. So it's 3 minus -9. Divide that by x2. Our x2 is -10 minus, what is our x1? -6. And of course from there we can see that this is 3 minus -9. That is going to give us 12, because these two negatives become positive. 12, divide that by, or down here it was -10, right? And -10 minus 6, giving us -16. When we simplify that, by 2 gives us 6, by 2 gives us 8. By 2 is 3, by 2 is 4, so it's -3 over 4. -3 over 4 is the gradient. So if the gradient of that line, M, the black line, is -3 over 4. Now what is the gradient of the green line, which you are calling M1? What is the gradient of the green line? Now remember, like I said, that the two, when you multiply the two, they're supposed to be giving you they're supposed to be giving you -1. In other words, the gradient of of the green line, multiply that by the gradient of the black line. The two, when you multiply them, they should give you -1. So we're trying to find the gradient of M1. Of course, this is this. Let's keep this, like saying -3 over 4 times M1 is giving us -1. Multiply both sides by 4. I mean by 4. So this goes with that. You remain with -3. M1 give us -4. Divide both sides by -3 by -3. This goes with that, this and that. M1 is equal to this negative score. It becomes 4 over 3. So it means that the gradient of the other line is 4 over 3. So it means that up here, when we come back here, the gradient of the green line, which we are calling M2, M1, is 4 over 3. Now that we have our gradient as 4 over 3, so we can go ahead, and find the equation of the line. So from here we can simply come and say we know that y is equal to mx plus c. So what's the value of y we are counting on? Remember, this green line is going through a point 2, 0. So this is our value of x, that's our value of y. So our value of y here is 0. So 0 is giving us our value of m, which we got as 4/3 times our value of x, which is 2, plus our value of c. So that's going to become 4 times 2, which is 8/3, is equal to c, that is equal to 0. So of course, when we make c the subject of the formula, this is going to become 0 minus 8/3, giving us c. Oh, this is 8/3 plus c. Okay. So meaning our value of c here is negative 8/3. So now after finding that our value of c is 8/3, then we can come here and conclude and say, therefore, the equation of that line y is given by our value of m, which is 4/3x plus c. Our c so happens to be negative 8/3, so it's negative 8/3. And so that's the equation of the line. We have answered part A. Now, when we are doing this number, we went through quite, let me call it a lengthy process to get the gradient of the other line. Let me just show you a shortcut here, down here. Okay, so let's say we have two lines. We have line M1 and we have line M. These are two lines. Okay, line 1 and line 2, and they are perpendicular. Let me do some simple exercise here. These are two lines, M1 and M2. They can either be perpendicular, they can either be parallel, they can perpendicular, so we have numbers here. We have line M1. Okay, M1 is let's say it's -2, 4, 3, let's call this a half. So let's just do a simple exercise here. You can pause the video and try this out. Try and give me the answers to these things here, just to make sure that you're on that par. All right. So if we have a perpendicular line, if two lines, M1 and M2, if they are perpendicular, what's the gradient of the second line? Okay. So if one of the gradients is, I want to show you a shortcut here. So if the perpendicular is this, if the perpendicular line, one of the gradients is -2, what's the gradient of the other line? Now, when there are two perpendicular lines crossing each other, the gradient of the second line, you just use these acronyms. It's the reverse reciprocal. Just use this reverse reciprocal and you'll be able to get your answer. For example, here, perpendicular, line M1, the line 1 is the gradient is -2. So what is the gradient of the second line? It is the reverse. By reverse, we mean that if this is negative, so this is positive, that's the reverse. Then reciprocal. If this is 2, it means the reciprocal of 2 is 1/2. So, and that is the answer. That is the gradient of the second line. Why? Because when we multiply this times that, you end up with -1, which is the law that governs lines that are perpendicular, that when you multiply their gradients, you get -1. Let's try the next. These are parallel lines now. We know that for parallel lines, their gradients are the same. So if the gradient of line 1 is 4, it means the gradient of the second line is also the same, because for parallel lines, the two gradients are supposed to be the same. Moving on to 3. This is perpendicular and it is +3. So if it is +3, remember that for perpendicular lines, we are going to use this reverse reciprocal. So if the gradient of the first line is 3, it means the gradient of the second line is going to be the reverse. But the reverse will mean that if this is positive, it means that the gradient of the other line is going to be negative. Now, if this is 3, it means that the reciprocal of 3 is 1/3. Why? Because when you multiply those two numbers, it will give us -1. So that's how we find, that's the shortcut for finding the gradient of the other line. Okay, Next, parallel. These two are parallel. So if we know that for parallel lines, the gradient of line y is a half, it means the gradient of the other line will also be a half, because gradients of two parallel lines is always the same. Then let's get to the next, perpendicular. I think by now you know what to do. Perpendicular, if the gradient of one line is 2 over 3 and it's a negative, for perpendicular we said we use reverse reciprocal. So the reverse here of negative is positive, so it means that the other is going to be a positive, right? Then the reciprocal of 2 over 3 is 3 over 2, because when you multiply those two, they give you -1, which conforms to the law that for perpendicular lines, when you multiply their gradients, they give you -1. Moving on to the next, these ones are also perpendicular. That is 3/4. The perpendicular lines, we are going to use reverse reciprocal. So the reverse of positive is negative, and then the reciprocal of 3 over 4 is 4 over 3, because when you multiply those two gives you -1. Then perpendicular still, these two lines are perpendicular, so if one of the gradient is 9, what's the reverse of +9? That is negative, is the reverse sign. Then the reciprocal of 9, 9 over 1, this is 1 over 9, because when you multiply those two it gives you -1. So in other words, what I'm trying to show you here in this small table is a shortcut. Rather than going through the long things that we went through to find the gradient of the second line, just put that in mind, that when you want to find the gradient of the second line, simply use this reverse reciprocal and you'll be able to get the gradient of the second line. Let's move on to the next number. So we have 2 points here, point P and point Q. Point P is 4,5 and point Q is -2,9. Find the equation of the line passing 3P and Q. There are two ways of doing this question. I'm going to do both of them. Okay, so let's the first way. We know that y is given by mx plus c. That's the equation of the line. Okay, so now that the equation of the line, let's substitute for p. So for p, for the value of p, we can say, now remember, for value of p, this is the value of x, that's the value of y. So we can come here and say, meaning that y, which is 5, is going to be equal to x. X is 4, so it's going to be 4m plus c. That is as far as value of point P goes, and that's our equation 1. Then point Q. For point Q, we know that our points, we have x, y. Our value of x is -2, our value of y is 1. So meaning that is going to become, we know that y is equal to mx plus c. So our value of y here is 9 is equal to m -2. Value of x is -2, so it's -2 times x plus c. That's our equation 2. So you realize that we have two equations. Oh, actually this is -2m. My bad. So you realize that we have two equations. We have equation 1 and equation 2, and we just simply solve them simultaneously to find the values of m and c. So this is going to become 5 is equal to 4m plus c. That's the first equation. Then we have 9 is equal to -2m plus c. Those are two equations. So as we're using elimination method here, it's going to become 5 minus 9. 5 minus 9, we end up with -4, right? -4 is going to be equal to, this is 4 minus -2, like 4 minus -2. This is going to end up being a plus. So it means like it's more like 4 plus 2, which is 6. So 4 minus -2, it's going to be positive 6m, yeah? So it's 6m, then c minus c, that is going to be 0. So yeah, you can just say plus 0. So that's going to become 6m is going to give us -4. Divide both sides by 6, divide by 6, so that this 6 and that 6 cancel out, by 2 twice, by 2 3. So what we have here as our value of m is -2 over 3. That's -2 over 3 right there. So after getting that, then we can go ahead and find our value of c by just substituting in any of these equations that we used earlier. All right, we can just say 9 is equal to negative 2m plus c. I've just chosen one of the two equations. So from those two equations, I substitute for the value of m to get the value of c. So it becomes 9 is going to be equal to negative 2 times my value of m, which I got as negative 2 over 3 plus c. So we are trying to find the value of c. So that means that my 9 is going to end up negative 2 times negative 2 is positive 4. Divide that by 3 plus c, something like that. So from here, we can go ahead and, find 9 minus 4 over 3. This is over 1 is equal to c. So that means the LCM here is 3, 3, divided by 1 is 3, 3 times 3 is 27. Then 3 into 3 is 1. 1 times, negative 1 times, negative 4. That's 27 minus 4. And so what is 27? 3 divided by 3 is 1. 1 times 4 is 4. So like that. So 27 minus 4 gives us our value of c. So this is going to become 23 over 3, giving us c. Now that we've gotten our value of c as 23 over 3, so we can go ahead and say that y is equal to mx plus c. So if y is equal to mx plus c, so it means that our value of y is going to give us, by our value of m, we got our value of m as negative 2 over 3 up there. So this is going to become negative 2 over 3x plus our value of c, which is 23 over 3, like that. So this is the equation of the line. We've answered that question. But let me try doing this question using a different approach. P and Q. Maybe this approach is a shorter one. We want an equation of the line going through P, which is 4,5, and point Q. If P is 4,5, then Q is negative 2,9. So that is Q, which is negative 2,9. We want to find the equation going through those, and we know that y is equal to mx plus c. So from here, we are going to first find the gradient. So we know that gradient is given by y2 minus y1 over x2 minus x1, like that, right? So what is our value of y2? Let's label these ones. Let's call this x1, y1. Let's call this x2, y2. So after labeling them, we come and substitute them here. So y2, we shall say this is 9 minus y1, which is 5. Divide that by x2, which is negative 2, minus x1, which is 4. So what we end up here with 9 minus 5, which happens to be 4. Divide that by negative 2 minus negative 4, which is negative 6. By 2 twice, by 2, 3, we shall end up with negative 2 over 3. So this is our gradient, which so happens to be our value of m. Now that we've gotten our gradient, which so happens to be our value of m, it means that we have gotten the value of m here. So we can just pick on any of these, equations to substitute for y and x, and then afterwards we shall get our value of c. So let's get point P, which is 4,5, like that, right? And substitute it there. So we know that y is equal to mx plus c. So this is going to become our value of m, which happens to be the gradient, which we got as m as negative 2 over 3 over here. So that's going to become negative 2 over 3 times x. Now this is our value of x, which is 4, and our value of y, which is 5, plus c. So from here, let's go ahead and find the value of c. So from here, it's going to become negative 2 times 4, which is negative 8 over 3 plus c is going to give us 5. So making that the subject to the formula, from here we know that this is going to become 5 plus 8 over 3, this is over 1, is equal to c. So we find the LCM here, it is 3, 3 into 3, 3 times 5, that is 15, 3 divided by 3 is 1, 1 times 8 is plus 8 is equal to c. So from here we are able to find that our value of c here is going to become 23 over 3. So now that we know the value of c as 23 over 3, coming back up here, we know that our equation, remember, is y is equal to mx plus c. We got our value of m as, remember, negative 2 over 3, and we have our value of c, we've got it down here as 23 over 3. So we substitute them up there and we say our equation is going to become y is equal to our value of m, which is negative 2 over 3x, and then our value of c is 23 over 3. So this is plus 23 over 3. This looks like it's a shorter method, but hey, there are many ways of skinning a rat. You realize that that answer we got there is the same as the answer we got earlier. And what's the answer we got earlier? Still here, up here. You realize that it's the same answer. Same answer we got here. Y is equal to negative 2 over 3x plus 23 over 23. So we've got the same answers. So it means that either method you use, you pick which is comfortable with you. There are many ways of skinning a rat, you'll still arrive at the same answer. Let's move on to the next number. Oh, I just remembered that in our previous number, I forgot part B here. I forgot to answer part B. So let's go ahead and answer part B of this question. I had skipped it. So here it is, part B. Let's get started with part B. A triangle PQR has vertices with coordinates. So let's try and draw that triangle PQR. Let me draw it here. The triangle PQR. Okay, that's now the part B. Now let's draw triangle PQR like that. So this is our triangle PQR. Okay, so they are telling us that the triangle PQR has vertices with coordinates P. Coordinate P is 3, negative 1. So this is 3, negative 1. And then we have Q, which is 7, 6. Q is 7, 6. And R is 0, 2. Now they're asking us to find the equation of its line of symmetry. So what is a line of symmetry? A line of symmetry is a line that is going to divide an object or a polygon into two equal parts. Now this is a triangle PQR. Let me give some examples here. If we have a triangle like that, and this side and that side and that side are the same, then that triangle is called an equilateral triangle, right? And so if it is an equilateral triangle, meaning that all its sides are the same, it means its line of symmetry can either be a perpendicular dropped from that point to come down. You see that line divides that triangle into two equal parts, or it can be a quadrilateral, a perpendicular dropped from that side onto right there, or it can be a line that is being dropped from here and it is going like that. That is if it's an equilateral triangle. I mean, it can have three lines of symmetry, but we do not know. But this is on condition that the sides are all the same. Now, according to our question here, we do not know if all the sides, if PR and RQ and QP are the same. Now, this is as far as it goes for an equilateral triangle. Then we also have triangles that are like this. They are called isosceles triangles. Isosceles triangles, only two sides are the same, and then this one is not the same, or two sides are equal. And for such triangles, they only have one line of symmetry. It's only one line that gets to divide the triangle into two equal parts. So now we do not know this triangle. Is it this triangle? Is it an isosceles triangle? Is it because determining whether it's an isosceles triangle or not, or whether it is an equilateral triangle or not, or is what is going to determine how we are going to deal, how we are going to approach the equation of the line of symmetry. So how are we going to find this out? We are going to find out by finding the lengths of these sides. We are going to find out the lengths of this side. When we find the lengths of those three sides, then we'll be able to verify whether it's an isosceles triangle or an equilateral triangle, or if it's not any of these two, because again, if it's not any of those two, it means that all the three sides are not the same, meaning this side is not equal to that side, it's not equal to that side. Then it will become complicated for us to find the equation of the line of symmetry. And we would not be able to find it actually using this information. It would be complicated for us. So actually, not even just complicated. There is no line of symmetry when it comes to triangles whose sides are not the same. As in, there is no one straight line that can divide the triangle into two equal parts that you can fold and they are overlapping each other. So in other words, if we calculate these three sides and we find that all of them have different lines, I mean different lengths, then there is no line of symmetry. So that's what we're going to go into. We're going to find line PR, its length, then we're going to find RQ, the length of line RQ, then we're going to find length of line, oh wait, where is this? This is P, yeah. This was P, and P is 3,1. So PR, RQ, and also we're supposed to find PQ. So let's get started. Now, when we're trying to find the length of a line, this is the formula. Now, I am not going to explain where the formula comes from or how it is derived. By the time you're doing these kinds of numbers, examination kind, I am assuming that your teacher showed you where these equations come from. I wouldn't want to go into those details when I'm answering these questions. But if you want me to show you where they come from, just let me know in the comment section below. So let's get to it. So we are finding line PR. So the formula is under the square root of, x2 minus x1 squared plus y2 minus y1 squared, like that. So that's going to be equal to, now what is our x2 and our x1? We have our value of p and our value of r there. So p here we said is 3, -1. This is -1. Let's not make that mistake. Let me make this a bit clear. So this is p into -3, -1. And then we have r. Our r is 0,2. So let this become our x1, y1, and this is our x2, y2, like that. So from there we can proceed with the working and know substitution. So this is going to be under the square root of x2. What is our x2? Up there it is 0 minus x1, which is 3 squared, plus y2. Y2 is 2, so it's 2 minus y1, which is -1, and this is also squared. So from there we will be able to get our answer. This is going to be under the square root of -3 squared plus, now 2 minus -1 is 3, so which is also 3 squared. And what answer do we have there? We have the square root of, 3 squared is 9 plus 9, like that. So what do we have eventually? So this is the square root of 18, like that. So we have PR as the square root of 18. So let's find RQ, side RQ. So again, we are going to do the same. RQ, I don't know why these they keep disappearing. R is 0,2, yes. So RQ still, we are going to say it's under the square root of, x2 minus x1 squared. This is supposed to be squared plus, I don't know why my ink keeps disappearing, plus y2 minus y1 squared, like that. Okay, so this is going to become under the square root. Now what is our x2? Now we are looking at RQ. So let's do it like this. Our RQ, let's say this is x1, y1, this is x2, y2. So this is going to become, so this is going to become our value of x2 is going to be 7 minus our value of x1, which is 0, this is squared, plus our value of y2, which is 6, minus our value of y1, which is 2, this is also squared, and that is going to become under the square root of 7 squared, that is 49, plus 6 minus 2, which is 4, 4 squared is 16. So 49 plus 16, what do we have? So 49 plus 16, what we have down here is, that is 5, 15, that is 65. So we have the square root of 65 as the length of our RQ. Like that. Okay. So let's go on and get the remaining, which is PQ. Okay. So we're going to find PQ. Let's do it here. So line PQ, again, we are going to use the same formula. It's going to be x2 minus x1 plus y2 minus y1. So what is our x2? What is our x1? Let's go and find out. So we're looking at PQ. To avoid over scrolling, let me put these things here. P is 3, negative 1. Q is 7, 6. And R, yeah, we only need PQ. Okay. So let's call this x1, y1, x2. This is x1, y1, then this is x2, y2, like that. So from there, we can go ahead and substitute it down here. So when you substitute that down here, we shall, proceed with this. It's going to become under the square root of x2 minus x1, which is, 7 minus 3 plus, this is squared, y2, which is 6 minus negative 1. This is all squared. So 7 minus 3 is 4. So 7 minus 3 being 4, meaning 4, that is going to get 4 squared plus 7 squared. That's going to be under the square root of 16 plus 49. When I'm to add 16 plus 49, I will end up with, this is going to be 5, 6, 65. And this is PQ. So we have gotten the three sides right there. As you can see, we have, this is our PR. So we have PR, the length of PR. We have PQ. We have, RQ and PQ. So if I may redraw that triangle up there, this is how it would look like. So let me redraw it down here. So that we're able to locate the line of symmetry that is being talked about. We know that this was our point P, which was 3, 1, negative 1. This was our point Q, which was 7, 6, and this is our point R, and our point R is 0, 2. And from there, we've been able to identify that PR is, the length of PR is the square root of 18. The length of RQ is the square root of 65. And the length of PQ is the square root of 65. So if you look at that, you're able to identify, you're able to see that actually this side and that side are the same. So if I may redraw this so that it looks upright, an upright, upright triangle, this is how it would be like. Our value of Q is what is going to be on top, Q, so that this side is the same as that side, that is Q, and down at the base we have P and we have R. We have our value of Q to be 7, 6, that's our point. We have our value of r as 0, 2, and we have our value of p as 3, -1. So what has happened here is that by us going to first find the lengths of the sides, we have been able to establish that two sides are the same, so this is an isosceles triangle. And when it comes to an isosceles triangle, its line of symmetry drops from up there down. This is the line that is dividing this triangle into two equal parts. And so when it comes and collides with PR, it divides PR into two equal parts like that. So meaning that this side is the same as that side, like that. So that's the line of symmetry for an isosceles triangle. And the question requires us to find the equation of the line of symmetry. So in other words, when you look at the line of symmetry, it is passing through 2 points. It's passing through point 7, 6. Then it's also passing through the midpoint of PR, this point here. So we need to find, so we already know this, now we need to find the midpoint of PR. After finding the midpoint of PR, then from there we shall be able to find the equation of the line of symmetry. Okay, so let's first find the midpoint of PR. So we know that the midpoint of PR, is given by, it's going to be x1 plus x2, divide that by 2, comma, y1 plus y2, divide that by 2. That's how we get the midpoint. So that's going to be equal to, now what is x1? So of course we are moving from P to R. So this will be our x1, y1, then let's call this x2, y2. So our x1 there is going to be 3 plus x2, which is 0, divide that by 2, comma, y1, our y is -1 plus y2, which is 2, divide that by 2. Then from there we are able to get the value of the midpoint, which is 3 over 2, comma, let me leave it in fractions, 3 over 2, comma, a half. So that's the value of our midpoint. So in other words, this equation, because let's get back to the question. The question is telling us to find that they're asking us to find the equation of the line of symmetry. We're supposed to find the equation of the line of symmetry. So we have been able to identify the line of symmetry, and after identifying the line of symmetry, we have been able to establish that this line of symmetry is passing through 2 points. The line of symmetry is passing through the point Q, which you have here, the point Q, which is 7, 6. So the line of symmetry is passing through point Q, which is 7, 6. And it is also passing through the midpoint of PR, which is 3 over 2, a half, like that. So in other words, we are trying to find the equation of a line that is going through these 2 points. So let's get started with the working. So we shall begin by finding the gradient of that line. So the gradient is given by, y2 minus y1 over x2 minus x1. So let's label these ones. This is x1, y1, x2, y2. So we proceed, y2 minus y1, so that's going to become a half minus y1, which is 6, divide that by x2, which is 3 over 2, minus 7. Okay, so what do we have? So what is a half minus 6? Definitely a half minus 6 is going to give us -5 and a half. And -5 and a half is the same as saying -11 over 2. Divide that by what is 3 over 2 minus 7. 3 over 2 1 minus 7 is also going to give us -11 over 2. And of course, when we divide those two, what do we end up with? When we divide those two, we end up with 1. Now somebody in the comments will ask me, where does the 1 come from? Let me go slowly. Okay, This is going the same as saying 11 over 2 divided by negative 11 over 2, which is the same as negative 11 over 2. Multiply that by 2 over negative 11. This goes with that, by this one, by that once. And definitely that is going to give us 1. So meaning that the gradient is 1. That's the gradient. It's 1. The gradient of the line of symmetry is 1. Now that we know the gradient is 1, so we can simply come back here and know that we know that our gradient is 1. But we know that y is given by mx plus c. Y is equal to mx plus c. That's the general equation of the line. We know. Let's just pick one of these lines. I don't know why my things they keep disappearing. I think after this number I'll have to restart my PC so that we get things in order. The things I'm writing keep jumping off. This is 7,6. Okay. All right. So let's just pick this point here. So it is 7,6. My value of y is going to be equal to mx. Our value of m is a gradient is 1 times x. Let's choose one of these points to get us x. Let's choose x as 7. So times 7 x plus c is equal to y. My value of y is 6. So this is 6. So 6 is equal to 1 times 7, which is 7, plus c. Again, this x is not there. So 6 minus 7 is negative 1, which is equal to c. So our value of c is negative 1. So from here we can see that we know that y is equal to mx plus c, so which is the same as y is equal to our value of m, the gradient, which is 1, so it is 1x, so which is x plus c. Plus c, our value of c is negative 1. So in other words, the equation of this line is y is equal to x minus 1. So this is the equation of the line of symmetry, and that's the answer. All right, so I think we are done with that question. We've answered it, so we're moving on to the next. So let's look at this one. In a certain supermarket, a school bag costs B shillings and a pair of stockings costs S shillings. So we have a school bag and a pair of stockings. So in a certain supermarket, a school bag costs, so let's look at cost. A school bag costs B shillings and a pair of stockings costs S shillings. Kato bought 3 school bags, so Kato bought 3 school bags and 2 pairs of shoes, and he bought those as wait, this is not stockings, it's shoes. The question says that in a certain supermarket, a school bag costs B shillings and a pair of shoes. So this is a pair of shoes. So that pair of shoes costs S shillings. Kato bought 3 school bags and 2 pairs of shoes, and he bought these at 103,000. Okay. And a team, now this is Kato. Now a team, let me use red for a team. So a team bought 5 school bags and 1 pair of shoes at 132,000. So they want us to find the cost of a school bag and the cost of a pair of shoes. So definitely these are the amounts that were bought. These are the prices, the cost. So if we are to look at, for example, when you look at Kato, if you look at Kato, which I have highlighted in green, Kato bought 3 bags. So if the cost of each bag is B, it means that the total cost of the bags is going to be 3 bags times the cost of each bag plus the shoes. We bought 2 shoes and the total cost of each shoe is S. So it is 2 times S. This is going to give us the total amount of money Kato used, which is this 103,000. Then for a team, same story. She bought 5 bags, so it's 5 bags times the cost of each bags plus the 1 shoe she bought, 1 pair of shoe times the cost of each pair of shoes, which is denoted by S, gives us the total amount of money she spent, 132,000. So that formulates two simultaneous equations that we are going to solve. So I will solve the simultaneous equations using, I'll use elimination. So let's get to it. So this is 3b plus 2s is equal to 103,000. Then we have 5b plus 1s giving us 132,000. So in the second equation here, let's eliminate s. So in order for us to eliminate s, it means that the coefficient of s have to be the same both up and down. So the coefficient of s in the first equation is 2, the coefficient of s in the second equation is 1. So we multiply the second equation by 2 to make sure that the two are the same. So what we have now is 3b plus 2s is going to give us 103,000. Then we have 5 times 2, which is 10b, plus 2 times s, which is 2s, giving us, so this is 132, multiply that by 2. 132 multiply that by 2 is going to give us 264. So that being said, so now we can go ahead and eliminate. So we're going to say the first equation minus this minus that. So it's 3b minus 10b is going to give us negative 7b. Then of course 2s minus 2s is 0, is going to give us 103 minus 264. That is going to give us negative 161, 000. Divide both sides by 7, divide both sides by 7. In other words, negative 7. So our value of b is going to be equal to 23. This goes with that, we remain with 23,000. So if that's our value of b, so we've got the value of b, and in the question, the value of b so happens to be the price of a school bag. So it means the price of a school bag is 23,000. So I can go ahead and find the cost, the cost of a pair of shoes, which is denoted by S. We do that by just picking up one of these equations. So we shall pick up maybe the second one, which is saying 5b plus 1s is equal to 132,000. Then we shall simply substitute. We have 5 times b. Now the b so happens to be what we got as 23,000 plus 1s, which is the same as s, is equal to 132,000. So this is going to become 115,000 plus s, giving us 132,000. So my value of s here is going to be 17,000. So that's the answer. The pair of shoes cost 17,000. And finally, let's solve for the value of p in this expression. We have 4p minus 1, divide that by 3, minus 3p minus 1, divide that by 2, is giving us 5, minus 2p over 4. So we shall go ahead and find the LCM. 3 and 2, the LCM is 6. 6 divided by 3 is 2. So it shall be 2 times the expression on top, which is 4p minus 1, minus 6 divided by 2 is 3. Then 3 times 3, p minus 1, like that. This is equal to 5 minus 2p over 4, like that. So from there, we shall go ahead and open the brackets. 2 times 4 is 8p minus 2. 3 times 3 is minus 9p. Negative 3 times negative 1 is plus 3. Divided by 6 is giving us 5 minus 2p over 4. So we collect like terms. Up here, this becomes 8p minus 9p minus 9p minus 2 plus 3 divided by 6 is giving us 5 minus 2p divided by 4. So from there, what is 8 minus 9? That is going to give us negative 1. So it's 8p minus 9p, which is negative p. Negative 2 plus 3 gives us, plus 1. Gives it over 6. Is going to be 5 minus 2p over 4. Well, let's cross multiply to make it a flat equation. When we cross multiply, what we have here is 4 outside the brackets, 4 times negative p plus 1. That is what we are having along the diagonal. Then along this diagonal, this is going to be equal to 6. Multiply that by what is there, which is 5 minus 2p. So 4 times negative p is negative 4p. 4 times 1 is plus 4 is equal to 6 times 5, which is 30. 6 times negative 2, which is negative 12p. Alright, so this becomes negative 4p. Let this one come this way. It becomes plus 12p. That is going to be equal to 30 minus 4. So that gives us 8p. Is giving us 30 minus 4. That is 26. Divide both sides by 8. This goes by let's see, by 2. 4 by 2, 1, 3. So we have 13 over 4 as our value of p, and that's the answer.